Arctic winds, severe Arctic winds blasting Britain to a bitter -8 degrees Celsius temperatures.
What if our world turns into a giant block of ice? Picture everything around us, cities, forests, fields, buried under deep, cold ice because of something called Milankovitch Cycles. These aren't just big words. They mean Earth's path around the sun and its tilt are changing, pushing us toward a new ice age. Imagine places where kids play in the sun, now covered with thick ice. What if this icy takeover is closer than we think? Join us as we uncover, examine, and reveal what this chilling future might really look like. Earth's potential frozen future. Imagine a time when our entire planet was covered in ice, a snowball Earth. It's perhaps the most extreme kind of climate change we could imagine. Think of it as an ice age taken to the next level. This could happen because of something called Milankovitch Cycles, a term that might sound complex, but it's easier to understand than it seems. Beneath the ice, a mysterious microorganism is discovered, capable of changing everything we know about life. Picture glaciers appearing where you'd never expect them. These cycles play a big role in pushing us toward another ice age. They involve long-term changes in how the Earth orbits the sun and how much it tilts on its axis. These shifts in the Earth's movements help determine our planet's climate, setting the stage for expanding ice sheets. Now let's talk about the Earth's seasons and what causes them. Our seasons, spring, summer, autumn, and winter, are caused by the tilt of the Earth's axis and its orbit around the sun. The Earth tilts about 23.5 degrees, and this tilt has a huge effect on how sunlight reaches different parts of the world at different times of the year. This tilt, combined with the Earth's yearly journey around the sun, changes how much sunlight hits different places, which is what creates the 4 seasons. As Earth travels around the sun, different parts of the planet face the sun more directly at different times, leading to the changes in weather that we associate with each season. During the spring and autumn equinoxes, which happen around March 21st and September 21st, the sun is directly over the equator. This means day and night are almost the same length all over the world. In March, this marks the start of spring in the northern hemisphere and autumn in the southern hemisphere. In September, it's the other way around. These equinoxes are like moments of balance, where neither hemisphere is tilted toward or away from the sun. But this isn't where the story ends. Around June 21st, the northern hemisphere has its summer solstice, when it's tilted most directly toward the sun. This leads to the longest day and shortest night of the year, with the sun sitting high in the sky. Temperatures rise, bringing the warmth of summer. At the same time, the southern hemisphere experiences its winter solstice, with shorter days, longer nights, and colder temperatures. Then, around December 21st, things flip. The northern hemisphere reaches its winter solstice, tilting away from the sun. This creates the shortest day and longest night of the year, with the sun appearing lower in the sky and temperatures dropping. Meanwhile, the southern hemisphere enjoys its summer solstice, with longer days, shorter nights, and warmer weather. Because of the Earth's tilt, when it's summer in the northern hemisphere, it's winter in the southern hemisphere, and the reverse is true too. This opposition of seasons is all thanks to the way our planet tilts and moves around the sun. Even though these patterns have been steady for thousands of years, human activities are now impacting the climate, changing how intense and long the seasons can be and leading to higher global temperatures. Let's dive deeper into how our changing climate is reshaping our world. The unseen shifts. But wait, there's more. What if these changes only get more extreme? As we continue, let's explore what this could mean for our future on this planet. The changing weather patterns have made summers hotter and longer, while winters are shorter and less severe. This shift is also causing unpredictable seasonal changes in different parts of the world. These changes are important for ecosystems, farming, and communities everywhere. Understanding why Earth's seasons change is becoming more important as we see the effects of climate change getting stronger. Scientists are still learning about our planet's climate systems, and it's essential to think about how these changes could affect the regular patterns of the seasons and life on Earth. To be more specific, the summer solstice happens around June 21st, when the northern half is most directly pointed at the sun. This day has the most daylight and the shortest night. This extra sunlight makes summer the warmest time of the year in those regions. On the other hand, the winter solstice occurs around December 21st, when the northern half faces away from the sun, resulting in the shortest day and longest night of the year. The limited sunlight explains the colder temperatures typical of winter. Meanwhile, during these times, the southern half of the Earth experiences the opposite conditions. But this isn't the whole story. Even though Earth's tilt hasn't changed, the climate is shifting, affecting how long and intense these seasons are. Rising global temperatures have led to longer and hotter summers and shorter, milder winters. These changes are impacting natural habitats, farming cycles, and weather patterns around the world. So, understanding how Earth's tilt shapes the seasons is becoming more critical to prepare for and adapt to these environmental shifts. It's also important to remember that not all parts of the world experience seasons in the same way. The tilt of the Earth, along with its latitude and geography, causes significant differences in seasonal changes. While many places go through the typical 4 seasons, other regions have unique seasonal patterns based on where they are on the globe. In temperate regions, which lie between the tropics and the polar circles, the year is generally divided into 4 seasons. This includes large parts of North America, Europe, and some areas of Asia. But this isn't the worst of it. Some areas might start to see even more unpredictable weather changes, like more frequent storms or longer droughts, making it harder to grow crops and affecting local wildlife. And so, it's not just about hotter summers or milder winters, it's about how these shifts will impact everything from the food we eat to the natural world around us. As the Earth moves around the sun, the way it is tilted causes different parts of the world to get different amounts of sunlight. This is what creates the seasons, or different periods of weather. In areas with a temperate climate, these seasons bring a variety of changes. Spring is when the weather starts to warm up, flowers begin to bloom, and animals become more active. It's a season that represents new beginnings and growth. Then comes summer, when the days become longer, the sun shines brighter, and temperatures rise. This season is perfect for outdoor fun, and it helps plants and trees grow lush and green. As autumn paints the leaves, we'll see how these changes signal shifts in our global climate. Sunlight and shadows at the world's extremes. After summer, autumn arrives, bringing cooler air and changing the leaves on trees to beautiful shades of red, orange, and yellow. This happens as trees get ready for the colder months by shedding their leaves. Then winter comes, bringing cold weather, often with snow and ice, especially in places further from the equator. Winter days are short, and the nights are long. But this isn't the same everywhere in the world. Near the equator, where it is tropical, there aren't 4 seasons. Instead, there are 2 main ones, the wet season and the dry season. The wet season brings rain, which is crucial for crops and filling up water supplies. The dry season has less rain and is much hotter. These changes happen because of a low-pressure area called the Intertropical Convergence Zone, which moves with the sun. In places farther from the equator, like the Arctic and Antarctic, the idea of 4 seasons doesn't really apply. Instead, the seasons are defined by extreme changes in light. During the summer, the sun doesn't set for a full 24 hours, creating what's known as the midnight sun, which provides constant daylight. But in winter, the sun doesn't rise at all, leading to long periods of darkness called the polar night. This might seem predictable, but here's the surprising part. Climate change is now altering these patterns all around the world. For example, rising temperatures are making summers last longer and winters less cold. Rain patterns in tropical areas are becoming more unpredictable, and the periods of continuous light or darkness in polar regions are also changing. These changes are important to understand because they affect not just nature, but also farming, culture, and communities everywhere. Many people mistakenly think that the seasons are caused by how close the Earth is to the sun. It seems like it would make sense that being nearer to the sun would mean warmer weather, but this isn't true. It's actually the tilt of the Earth that causes the seasons. The distance between the Earth and the sun changes only a little and doesn't play a big role. Yet, this is a common belief, showing how complex Earth's climate really is. The changing seasons on Earth happen mainly because of the tilt of its axis. The axis is tilted at about 23.5 degrees, which affects how sunlight reaches different parts of the planet throughout the year. During summer in the Northern Hemisphere, around June 21st, the Northern Hemisphere tilts toward the sun. This makes days longer and the sunlight more direct, leading to warmer temperatures. On the other hand, during winter, around December 21st, the Northern Hemisphere tilts away from the sun, causing shorter days and less direct sunlight, which cools things down. The Southern Hemisphere goes through the same seasonal changes, but in the opposite order. Its summer arrives when the Northern Hemisphere is in the middle of winter, and the other way around. Around March 21st and September 23rd, we experience equinoxes. During these times, day and night are almost equal everywhere on Earth because the tilt of the planet's axis is balanced with the sun. This chapter clears up common misunderstandings about what really causes our seasons. The dance of the cosmos. But there's a common misconception here. Seasons aren't caused by how close Earth is to the sun. Instead, they happen because Earth's axis stays pointed in the same direction, toward the North Star, no matter where it is in its orbit. This steady tilt causes different parts of the planet to lean toward or away from the sun at different times of the year. So, the angle of Earth's tilt is what creates our changing seasons, not the distance from the sun. When it's summer in the Northern Hemisphere, the days are longer because the sun takes a longer path across the sky. In winter, the sun's path is shorter, so the days are brief. These changes in daylight not only impact temperatures, but also affect weather patterns around the world, shaping different climates over time. But that's not all. Earth's climate also goes through long-term changes due to something called the Milankovitch Cycles, named after a Serbian mathematician. These cycles have three main parts: eccentricity, obliquity, and precession. Eccentricity deals with how Earth's orbit changes shape between more circular and more oval over about 100,000 years, which affects how much solar energy we receive. Obliquity refers to shifts in the angle of Earth's tilt, which changes how sunlight is spread out around the planet. But wait, there's more. The precession is like a wobble in Earth's rotation that takes about 26,000 years. These three factors combine over very long periods to influence Earth's climate, leading to ice ages and warmer periods in between. The tilt of Earth's axis changes slowly over a period of 41,000 years, swinging between just over 2 degrees and nearly 25 degrees. This tilt affects how different parts of the planet experience seasons. When the tilt is larger, the difference between seasons becomes more extreme: hotter summers and colder winters. When the tilt is smaller, the seasons are milder. Earth's axis also wobbles in a motion called precession, which takes about 26,000 years to complete. This wobble changes when seasons occur in relation to Earth's position around the sun, which affects how intense or mild they feel in different parts of the world. Recent breakthroughs in climate science, using data from ice cores, sediments, and advanced climate models, have greatly improved our understanding of how these long-term astronomical cycles have driven major climate changes in the past, such as the start and end of ice ages. These studies show that while these cycles, called Milankovitch cycles, have been key to shaping Earth's climate in the past, today's climate patterns are influenced by a mix of these natural cycles and human activities. This broader perspective helps us understand both Earth's climate history and its current changes. One of these cycles, called orbital eccentricity, refers to how much Earth's orbit around the Sun changes from being a perfect circle. This change happens over tens of thousands of years due to gravitational pulls from other planets and the Sun. The shape of Earth's orbit affects how much solar energy the planet receives, which plays a vital role in our climate. Right now, Earth's orbit is nearly circular, but this wasn't always the case. Scientists today use data from space missions and advanced models to understand better how these changes impact the planet's climate. Now, let's explore the ancient cycles that have been shaping our climate for millennia, exposing the mysteries of climate shifts. But that's not all. These cycles don't work in isolation. The interaction between Earth's orbital shape, the tilt of its axis, and its wobble combine to influence climate over long periods. Together, they determine when ice ages begin and end and how intense they are. At the moment, Earth's nearly circular orbit contributes to a relatively stable climate, but as this orbit changes over thousands of years, we could see more dramatic shifts in temperatures and the spread of ice around the world. The current tilt of Earth's axis, about 23.5 degrees, plays a crucial role in how sunlight is distributed across the globe, affecting weather patterns and the changing seasons. However, this tilt isn't fixed. Over long periods, it slowly changes through a process called axial precession. This gradual shift affects the severity and timing of the seasons, which in turn impacts climate patterns worldwide. Let's explore the Milankovitch Cycles, focusing on the second cycle. This cycle involves changes in Earth's axial tilt, which shifts between about 22 and 24.5 degrees every 41,000 years. These changes in tilt have a big impact on our planet's climate by altering how seasons are spread across the globe. When the tilt is at its maximum, we experience more extreme seasons, with hotter summers and colder winters. On the other hand, when the tilt is smaller, the seasons are milder, bringing cooler summers and warmer winters. Recent advances in satellite technology and studies of ice core samples show that Earth's tilt is currently decreasing. This gradual change is essential to understanding global climate patterns. For example, if the tilt keeps decreasing, we might see cooler summers and warmer winters over the next few thousand years. This could change glaciation patterns and broader climate trends, affecting global weather and ecosystems in significant ways. But that's not the only factor at play. Scientists have also found connections between Earth's axial tilt and other parts of the Milankovitch cycles, like the shape of Earth's orbit around the Sun, known as orbital eccentricity, and axial precession, which is the wobble in Earth's rotation. These cycles together influence long-term climate changes and help us understand historical climate shifts, like ice ages. The way these cycles interact can either make the effects stronger or weaker, leading to complex climate outcomes. But this isn't the end of the story. Understanding these cycles is essential for predicting what might happen with our climate in the future. The ongoing decrease in Earth's tilt might counterbalance some of the warming trends forecasted by other climate models. However, human activities, especially the release of greenhouse gases, are currently the main drivers of climate change and could outweigh the impact of these natural cycles. As scientific research continues to advance, it's clear that monitoring these cycles closely is important for making accurate predictions and managing the long-term impacts of climate change. The third cycle, called axial precession, involves a slow shift in Earth's rotational axis, caused by gravitational pulls from the Sun and Moon. This wobble occurs over about 26,000 years and affects the timing of our seasons and climate patterns by changing how Earth aligns with the Sun. Changes in the timing of solstices and equinoxes, influenced by precession, can lead to differences in the intensity and length of seasons worldwide. When the axis shifts, it changes how the Sun's energy is distributed, which then interacts with the other cycles to further shape our climate. These ongoing changes show just how interconnected and dynamic our planet's climate system is, highlighting the importance of continued research and observation to understand what's happening and what might come next. What do you think? Could these shifts lead to irreversible climate changes? Comment your thoughts below, and don't forget to subscribe for more discussions.